Good afternoon, everybody. How are we doing? Got a very packed agenda today. I'm very excited. Just getting all my stuff put together here. Make sure I'm recording. Wouldn't want to miss anything for all the folks that may not be able to join us live. All right. Naman, how you doing? Good to see you.
Yeah, you too. Just finishing our lunch over here and jumping on the call.
Nice. Morgan, looks like you're on the way. Are you on the way to Denver? Still almost there. All right. Rep our Phase Zero Sorbonne.
Yeah.
Yes, I think we have to start with a massive congratulations to all of us. We got Sorbonne on mainnet, Protocol 20. Some might say only 2.5 years. I say 10 years in the making. Pretty impressive. All right, well, we've got a packed agenda, so I am going to move us right along. First on our plate is Chad, who's popped on screen here. He's going to be taking us through the TypeScript bindings. For those who are unaware, oh my goodness, hopefully you're aware, the CLI can generate TypeScript bindings for your contract. So you have a fully typed contract that you can begin to invoke. However, Chad and his team at AHA Labs are always moving quick and breaking things. So I think it's helpful every now and then to bring us all up to speed on the latest and greatest of the TypeScript bindings so that everybody is aware of all the cool things that you can do right now and then also what the future may hold. And so I'll hand it right on over. As you have questions, feel free to pop them in the chat and then I'll surface those up to you, Chad, so you can pay attention to your presentation. Sound good?
Sounds great. All right, let me share my
Awesome.
screen. I accidentally quit
You might.
Podman, so hopefully,
Let me make
can you hear
sure
me?
yes, I can hear you just fine. Let me make sure you've got permissions. You may have to, I have to add speaker permissions. You may have to, oh, look at that.
There.
It's perfect. Maybe. Awesome.
All right, Podman's running. My quick start is running great, so we'll be able to actually do this. All right, there's a new Sorbonne CLI version on the way, and it's going to have this great Sorbonne contract init command. If we do -- help, you give it the name of a project, init project path, and then you can do all the examples from the Sorbonne examples repository, and you can pass a front-end template. So I already made a project called LOL. We'll use this as a demonstration here. This is not the published version of Sorbonne CLI. This is the built from the main branch. So I just have which Sorbonne? That's a symlink. If I search my history, you can see that I just symlinked my actual CLI's target debug Sorbonne to my cargo bin directory. So that's what's happening here. That's why I can use this. But you'll be able to use it soon too. So anyway, let's say init, and I want to do it with the increment contract, and I want to use this front-end template from a separate project that's currently going through review for Stellar Community Fund. And we're going to call it LOL2. We won't have to wait for it to build, but you can see what happens here. It puts in a hello world contract. It puts in the increment contract with increment. And so if we change into LOL2, you can see all this stuff in the contracts directory. I also included a front-end template, so I've got a bunch of JavaScript here, but if I hadn't done that, all I would have is the cargoes and the contracts folder. So the reason I like this template is got some nice stuff for automatically building. Right now, it's just in an initialize file that is styled like a Bash script because it used to be a Bash script. But it is just looping through everything in contract, and it's generating TypeScript bindings for them. So first it has to deploy them to the chain. So you can see down here at the bottom, it's calling fund all. Fund all is creating some accounts. Keys generate process.env.sorbon account. And in there, we're telling it to use Sorbon account is me. So it's generating an account called me. And then it is building all of our contracts. It removes the old ones and then just runs Sorbon contract build. And then it's deploying them all. So it loops through all of the WASM files in target WASM32 unknown release and deploys them all. And then it binds them all. Sorbon contract bindings, TypeScript, contract ID. This is the whole thing. Let's turn on line wrapping so you can actually see it. And then you tell it an output dir. The output directory here is in this packages folder, which is part of our NPM workspace. This is my first time using NPM workspaces with mixed results so far, I would say. Whoa, it's all in one line. That's exciting. Can we tell it to format that? Yeah, great. Okay, so workspaces is packages/splat. So you don't need Yarn anymore. You can use NPM with workspaces. And then the stuff that's in workspaces automatically gets symlinked from node modules to your packages folder. So that's cool. We can go back to initialize.js. So after it binds them all into packages JSON, right, it loops through all of the contract. Oh, yes, I skipped over one small detail in the deploy. It is outputting all of the, as it deploys them, it's saving their IDs to the .sorbon/contract IDs folder, which is obviously get ignored as the entire .sorbon folder is. So you can see that we've saved those. Someday that should really be included in the CLI itself, but for today, you can use some scripting to pipe the ID into a file. So that's where those files are coming from. So after it binds them all, looping over that, it imports the contract. So the other thing this little script even does for us is it creates this file for each of our contracts in source, contracts, and then contract name. This contract name, if you're not totally familiar with it, is from the cargo.toml, Sorbon Hello World contract. Sorbon Hello World contract. It changes from kebab case to underscore case. So here it's just importing Splat as client from that library, and then it's exporting client.contract, and it imports the standalone network, right? Like this should work with any network today. This script is just putting in the string standalone. So not super, it's fairly brittle. It wouldn't work with testnet or FeatureNet. Yeah, so that's the import step. So it funded accounts, built all our contracts, deployed all our contracts, bound all our contracts, imported all our contracts, and now we're ready to go use them. Any questions here? I'll stop and make sure there's no confusion about what we did so far.
I don't see anything yet. This just to be clear, this repo that you've posted, this came from that init command that just like cloned a repository.
Yes,
into
with
this?
some modifications because the template repository is a little bit like in its early days still.
Sure.
So there were some things missing.
Sure, but the idea is pretty cool where you've got this new init function that's coming, and then the community can kind of essentially just build out templates that you can then kind of bundle up into these repos where you've got a whole directory ready to go. And in this case, you've got all kinds of good fun stuff like this whole initialize.js function, which takes everything, including contracts, builds it all together. So you've got a fully working dApp. Pretty cool.
Exactly.
And
Yep,
this is hard
and then
coded. This
this-
particular one is hard coded to the standalone network, right?
It is, yeah. Whenever it does this import all, it's just hard coding standalone here.
Yep.
Yeah.
Cool.
And the goal is to eventually make this template not hard code standalone. But for today, that's the easiest place to start.
Very cool. Press on.
All right. So this is using a front end framework, if you want to call it a framework. I don't know what to call anything in front end world, called Astro. Astro has its own templating system. What I like about its templating system is that it's not using, I love React, but React is like too much for some apps, for a lot of apps. And I think like to see it clearly, I like to see it with plain JavaScript, right? I want to make sure that everything that we make works with plain JavaScript. So in Astro templates, all this stuff gets executed on the server. So right now you can see that we're importing our hello world contract from that auto-generated contract / Sorbonne hello world contract. As a refresher, that's just importing our contract client and then exporting an instantiated version of it. I'm gonna close some stuff. Sure, save that. And then we're going to ignore the fact that we're not using that incrementer yet. You can see that we create a greeting. So we've imported a hello world contract, and you can see here, this is all auto-generated from the contract, right? Construct and simulate a hello transaction. Returns an assembled transaction object, which will have a result field, as you can see here, containing the result of the simulation. If this transaction changes contract state, you will need to call sign and send on the return to object. We'll see that soon. So then we're saying hello to y'all. And then if we go to our front end, let me make sure that it is running. Host invocation failed. Run. This is using Bash. I almost never use VS Code, but Astro's templates work a lot better with VS Code than with Vim. There's like no support for them in Vim right now. And I can't tell if NPM workspaces work okay in Vim or if it's just Astro templates that I'm having problems with. Okay, so we see there whenever I ran my dev server, it was also rebuilding all of this stuff, looping through everything in contracts, deploying them, setting up my source contracts folders or files, all of that. Great. So hello, y'all. We can see that it's working. If I refresh the page, cool. And just one fun thing about Astro, since we're in Astro, I can tell you about it. Everything inside this front matter stuff is executed either at build time and then just deployed as static HTML, or in the case of running your dev server, on your dev server. So I can say hello to Sorbonne. Sure, hello to Sorbonne. Let's just keep it simple. Failed to save. The content in this file is newer. Overwrite. Hello, Sorbonne. There it is. It already refreshed. Actually, I think if I move that to the left, and then I hide that sidebar, I hide that. Wow. Yeah, hot reloading. Okay, so we've got this incrementer. So we can see how we call hello world, and we can see that if we say hello world dot, we get the type ahead, right? Dot. And we get Copilot suggesting nonsense. I don't want Copilot. Let's turn off Copilot. Pilot. Extensions. Show running extensions. Install extensions. Copilot. I just want to turn it off so it's not distracting. Disable. Thank you for bearing with me. Okay, hello world dot. There we go. That's so much better. Nope, Copilot is still going. I think I'm gonna have to restart VS Code. Is that true? seems to be true.
I have
Hello
no idea.
world dot. Yay! Okay, great. Okay, and it looks better in this wider view also. So you can see all of the information there. Something else that I should show, actually. Let's do this while we're here. Let's open up contracts. Hello lib.rs. There's no documentation comments on here. Say hello to someone or something with exclamation marks. And now if we rerun our run dev. So this is going to rebuild the contract clients for all of those and re-import them. So if we jump back up here and we go into index.astro hello world dot, and now we'll be able to say hello to someone or something. There's no space. So let's file a bug report and add a space or maybe a new line. But yeah, that's an easy fix. But all of the comments from the original code author end up in these libraries. And I want to stress those comments live on chain, right? Like that's in the XDR that gets embedded in the WASM file, which lives on chain. So this isn't some magic because I have those the contract source on this machine. You would be able to have this same quality of like front end interaction pattern, even with someone else's contract that you've pulled off of the blockchain. So if you haven't used this TypeScript binding stuff, that's some of what it gives you. Let's see this incrementer one because that's where we're actually signing and sending some stuff. So let's just replace the contents of this with incrementer or with a counter. That's what it is. And I think import counter from component counter, and we don't want to do incrementer there. And did I do it right? I did. Increment, updating, and what? And some JavaScript error is my guess. Increment, updating. Yeah, look at that. That's fun. Axios error. Ha! Tyler loves Axios. Error bad request. Doing it live, y'all. Fun times. Maybe we don't get bogged down with fixing that particular bug and we just go to counter. So this is importing incrementer from the same way that we imported hello world over here. Import hello world from contract, Sorbonne hello world contract. Import incrementer from contract, Sorbonne increment contract. And then whenever you click on the button, it is going to increment, await incrementer increment. I mean, that's part of the problem. We need to actually sign and send it. This file that I copied in here is a little bit old. So really, we want to say const transaction equals await incrementer dot increment. And then new value equals await transaction sign and send. And let's see how that works now. No, it still doesn't like it. We're still getting a bad request. I bet that's because I don't have Freighter enabled. That's almost certainly it. Oh, no application defined. Fun. Okay. Fascinating. I don't know what button I pressed. Cool. Fund with FriendBot account for JDG. And will that work? Still getting a bad request. My guess is that we need to import connect freighter from components connect freighter. And we'll put that right down under this heading. Connect Freighter. Please switch to testnet. That's not true. Please switch to standalone. HTTPS, no S, localhost, 8000, Horizon. Is that right, Tyler?
I think it's probably the Sorbonne / RPC, right? Or is that? Oh wait, if it's
For
the,
Horizon.
if it's Horizon, there's no /. It's just the root.
Okay, cool. And the passphrase, I'll have to go copy that from my .env.
Friendbot is
Yes.
/ friendbot. I think.
Thank you. Yeah, it is. I just forgot to update it.
It doesn't look like it worked.
Let me pin Freighter.
Look at the
Address is not funded.
settings again.
Account already exists, so it is funded.
Yeah, it's weird. It's not showing up.
So my settings must be wrong.
Maybe remove that /
On here?
Yeah.
Huh.
Huh. It's also, yeah, I don't know.
Interesting. Okay. Well, and then we've got this wallet in here that is expected network equals testnet. Get rid of expected network. I think maybe that's fine. Expected. Okay, signed in as JDG. Let's see if this works now, even though this thinks I'm not funded. And if I'm not funded, then we would still expect to get this error. So something with my network settings is wrong. That's a bummer. I kind of don't want to troubleshoot it on this call. Tyler, feel free to tell me if I should, but I think there's enough to get into with just looking at the code that we don't need to worry about it.
Yeah, I wouldn't worry about
Is
it.
that fair?
Yep.
Okay, so we see here that we do incrementer.increment and then transaction.sign and send. And we also see when we import those files, right? Contracts / hello world inside. Do I already have it open? No, I don't. Let me open my sidebar. File Explorer. Contract, Sorbonne Hello World. Right now, today, this is just magically importing Freighter, right? Like that's it's kind of surprising that this is working with Freighter at all. So coming down the road, you will have to like import Splat as Freighter from seller, whatever it is. Is it seller / Freighter? And then you'll have to pass I think we're calling it like a Sorbonne signer is Freighter. And that'll make it easier to work with this in other environments. Or you don't have to pass it here. You can also pass it whenever you do the individual call. You can just pass, if you pass nothing here, no Sorbonne signer, you could also pass a key pair. And if you don't pass either of them here, then you can still make view calls because you don't need to sign anything for view calls. But if you're doing something like this, where you need to sign and send, then you will need to pass the Sorbonne signer there. Sorbonne signer is Freighter at this point. Something like that. So that's one change that's coming down the road. One other change that's coming down the road is that the guts of this, if we go into that packages directory I talked about earlier, where we're actually like generating these libraries, these are NPM packages that are generated for whenever you run Sorbonne contract bindings TypeScript. It generates a whole NPM library with its own package.json and its own dependencies. And then in the source directory, it's all TypeScript. And in here, you can see all of the, like, this is where that public read only, or where hello is defined. So this is where that hello definition lives. This is kind of like silly to copy and paste a whole bunch of the same stuff. Like this assembled transaction logic is just copy pasted into each one of these that you make right now. These are exactly the same. So all of this, the guts of this are all moving to Stellar SDK. We'll use code splitting so that you don't have to import it if you're just doing lower level stuff with Stellar SDK. But if you want to use this stuff, you don't even have to use TypeScript. You don't have to use the bindings. You'll be able to import the bulk of this contract client logic and use it dynamically in a front end. Pull a contracts XDR down, just give it the contract ID, it'll pull it off chain, it'll generate a whole contract client on the fly, the same kinds that you saw me interacting with here. It'll have all of the comments from the initial author in there. The only thing it won't have is typing, because you need to do that at build time. So that's where the Sorbonne contract bindings TypeScript comes in, is it will give you types, and it'll otherwise just use that same logic that you'll be able to use dynamically in the front end, and it'll just wrap it with some TypeScript niceties. So that's kind of a quick. It wasn't even that quick. It was a half hour, but that was a tour of what you can do with the TypeScript bindings today, and a little bit of what is about to happen with it. Any questions?
I don't see anything. Some conversations
Crickets.
about init. This is super helpful. I know I am in love with where this project has gone. Being able to have TypeScript bindings for contract, I just love it.
Great. Thanks for having me, Tyler.
Of course. Thanks so much for jumping on. Really appreciate it. Hopefully, with any luck, we'll actually have this recorded and folks can follow up on it. Maybe we'll even be able to figure out how to get Freighter to work on a standalone network one day.
That would be incredible.
That would be incredible. All right. Thank you so much, Chad. Really appreciate it.
Yep.
All right. Moving on to our next phase here. We want to talk about RPC. So this was not in any way unexpected, right? So Sorbonne hit phase 0, and smart contracts made it onto Stellar. But we've all been developing with the assumption that we don't have to run our own RPC endpoints, that it will just be magically provided for us forever. And that will probably be true for testnet and like developer networks, and even like quick starts, very easy to spin up local networks. But for mainnet, that will not be the case. You'll have to figure out your own ways to either stand up your own RPCs, use providers out there in the ecosystem. There will be indexers, a whole host of tooling. I think that's really important. It may be a little bit inconvenient at first, particularly because we're used to having, SDF Horizon endpoints, but it's important, particularly for decentralization, that we don't have single points of contact APIs that the whole majority of the ecosystem are using. It ensures that we have some healthy competition, providing good uptime and fixing bugs and providing new functionality, things like that. But it did, I think, catch a few people by surprise. Even with phase 0, where you really can't do much of anything on the network, people wanted to try. I know I certainly did. And so there was a bit of a scramble to figure out, okay, where's the RPCs though? Well, there is a list. This has been shared around. I'm going to paste it in the chat here, if I can find my chat. Perfect. And that's got a good, solid, strong list of initial RPC providers. I think there was one more that's not yet on this list. Anchor, ANKR. I don't know if they have mainnet support, but I've personally walked down through each of these, and some of them don't have mainnet support yet. The ones that I have definitely tried and have endpoints for and have tested them is QuickNode and Gateway. Feel free if other people have tried other ones of these and can confirm that they have mainnet support at this time. But I definitely know QuickNode and Gateway do support mainnet right now, which is awesome. But I also want to note, if you want to run your own RPC endpoint rather than relying on a third party, that is also quite possible. That was the first few days of my scramble, was to figure out how to actually get a mainnet RPC stood up. I'm used to using the Docker quick start, and man, I haven't stood up a public quick start in a very long time, and my goodness, it's very resource intensive. I think you need like 150 gigabytes. I don't know exactly what the memory resource consumption is, but I think it's like 32 gigabytes or something. I've got a very beefy machine and I couldn't get it to work. I think there were some initial issues that I believe Lee has sorted out where the RPC endpoint wasn't even supported on the tags or the deployed containers. So there was a bit of a scramble on the quick start. But Robear reminded me that there is RPC usage. I'm going to paste another link here. I keep losing my Discord chat. There's another. Did you know, because I did not, that there's actually a Docker image for just the RPC. So rather than, so the issue with Quick Start is it's running core. I think it's by default a validator. It's also running Horizon, which is a really big resource hog for both memory and storage. It's also running the RPC. You've got the Postgres databases, obviously. So it's got a whole bunch of stuff. RPC is actually relatively light. And so Robert pointed me to this beautiful piece of technology where you can actually run the RPC, just the RPC, which is amazing. And when I started poking around with that, lo and behold, in like 30 minutes, well, okay, it takes like an hour to catch up, but 30 minutes of fiddling around and some back and forth, I had this stood up and I've got it running on a machine that has 8 gigabytes of RAM and 4 CPU and I think 160 gigabytes, and it takes like maybe 40 or maybe 60 gigabytes of hardware of hard drive space. So not bad. Yes, a Raspberry Pi almost. So that's kind of what I would suggest you use. Now I'm going to really quick, because we've got a little bit of time, because I also want to, well, yeah, let me share my screen because that's fun. And hopefully I share the right one. Okay. I'm going to just like walk you through how you get that. Is this big enough? Is that large enough text? I never want to go larger than I have to, but I want to go sufficiently large. And just kind of walk you through how you would stand this up. Not even sure what this is. I'll get to this in just a moment. But this is the piece that we need right here. So go back to that piece of documentation here. Whoops. Oh, come on. There we go. It's a bit, I mean, the quick start is like a tiny little command. And this one's got, I mean, whenever I see the validators keyword in a big TOML file, I get nervous. And when I see lots of flags, I start getting nervous because I don't know about you, but if you've ever tried Docker and you see a lot of that, you know you're in for a time trying to figure out what your values should be. But it's not as bad as it looks. And I think I'm probably going to push for an update on a couple of these. So PR incoming. But you don't actually need to change anything in this except for a couple of these flags, which again I'll get to in a minute. The thing you need to keep an eye on are these two flags. And then if you're going to be running mainnet, you need the actual public. This is the testnet validator version. So the place where you can find that, the one that I copied it from, is if we go, just over to Stellar really quick, and we go to the quick start. That's probably really small, but squint. There's a pubnet core, etc., and a Stellar core config, and you can just copy this. There's a couple pieces, fields we'll need to change here, but you can just copy that. I'm going to go ahead and do that and paste it in here. The pieces that we need to change on this part, we don't need some of these, and we also don't need a public HTTP port. But that you can all just grab from this a bit. But this will give you like all of the validators that you need to actually catch up with the network. We don't need the catch up recent. The one thing we want to make sure is we've got the public network passphrase. And the rest of this we can toss. And then we'll save that. And I've saved this inside the Stellar Core CFG file. I don't think the file name matters because you're going to set it in this Sorbonne. So I made a little bash script here, Sorbonne RPC.sh. So this is basically, where's that Docker bit? That is this thing with some modifications. So let me just go ahead and copy that and highlight the modifications I made. Oops, that is commenting it all out. Tab. I may give it a name because otherwise, if it doesn't have a name, every time you like restart it or stop it, you'll spin up new ones, and that'll consume a lot of resources really quick and also start to confuse you. So I like to give my containers a name whenever I start them. So I have a name on mine. This is the mount volume. So this is the piece where you're going to get the Stellar Core config. Mine's, since I'm going to be running this RPC from this root of this directory I've got here, mine does not have a name. It's just //. So that's what that piece would be. And the rest of this, I'm not going to change for my volume. The captive core config path, I don't change except for this piece, which is the name of that file. So I think, Robert, you made a tutorial. Did you link it? Yes, excellent. He's using a .toml, so if you use .toml, use that. The rest of this, none of this changes. There is this piece. This flag doesn't exist anymore, so you want to remove that. The only other thing that I know I change, other than removing that endpoint, is also remove these like admin endpoints for metrics, which I don't use. So I toss all of that. I think the rest of this, make sure you're not using the test. You're using the public passphrase. We don't have a friend bot on public network, so you can toss that. Some of it's a little bit more obvious than others, but at the end of the day, you should end up with something that looks basically just like this. Yes, in the history archives, make sure that is the core live, not, I think it's testnet. So you don't want that. I don't think, make sure I didn't actually change anything there. Good. Make sure it's got the name. And then you go back to your project root, and then I'm just going to run that Sorbonne RPC SH. And then that will pull down the Docker image and then begin doing its thing. Looks like that failed because I'm actually running a quick start for the next part of my tutorial. So I'm actually going to kill that real quick to prove to you that this is actually going to work. We have a conflict because we already have the Sorbonne. So if we do docker ps dash, this is why we give things names so that we don't spin up bunches of these. Docker rm is to remove. Sorbonne RPC, remove that, and then we just run that again. And it's going to pull all that, and it'll start doing its downloading and catch up. I think this takes like an hour. We don't have that kind of time, but this is how you could get it running locally. I'm on a Mac. I have no idea if this works. I've got another DigitalOcean droplet that's running this in a Ubuntu container. So I'm going to kill this, but this will just do its thing, and eventually it'll come online. You can use Postman to do that Git health check, or just curl request. Again, it takes some time, but it uses way less resources than the quick start. Okay. Wonderful. I actually don't know if Command C is going to work to kill this. So we're going to do the Docker again, stop, Sorbonne RPC, which will kill that. Okay. So I've glossed over the RPC. Do we have any remaining questions on that? I think there may have been Billy or others that are in the chat. I don't know if anybody wants to add anything. Feel free. If there are additional things that should be said about RPC service providers. Looks like, Enrique, you've got a couple of running it on the cloud. Good, super good, helpful information. Yeah, the issue with the Raspberry Pi is I think the architecture is different. I don't know if we have images that work. It even, I think, throws a warning when you try to do a pull on this, which I think I've already got my pulls, but yeah, the requested image platform, they only build right now for Linux AMD 64s, which even Mac is an ARM 64, and I think most Raspberry Pis are another architecture, which gets a warning, but it's not an error, and it actually works on Mac, and I think that's probably because underlying, like what was it called, Rosetta or something, underlying, you can still run some of these, so who knows, but it did work for me. Okay, I don't see anything else here, so we will continue to move right along. So the next thing, obviously, nobody wants to just run an RPC. What you actually want to do, why don't I have my camera on? That would make this a little more engaging. Cool. With our RPCs, you don't want to just run them. You actually want to use them. That's the whole reason that you stand them up. Right. So once you've gotten an RPC, and you know, over the last few days, quite a few of us got our RPCs stood up, and then we ran into those phase 0 issues. They're not issues. We all knew it was coming, right? But come on, some of us have waited a very long time to execute smart contracts on mainnet. So did you really think we were going to wait until a week for phase 1? Of course not. We were going to do whatever we could. And I'm so upset with myself. Morgan and I had a call yesterday, and I should have recorded it, because Morgan was banging his head against a wall with these like CPU constraints, trying to figure out the leeway to actually get contracts invoked. And he lost his mind when he finally got these things submitted. And it really reflected to me that it's not about doing something useful right now. It's just the fact that we can do something on mainnet with smart contracts. We've waited a really long time for this. Yeah, so all of that to say, yes, I cannot wait for phase 1, 2, 3, and beyond. But phase 0, this is for the devs, right? Before the users come flooding in, phase 0 is for the devs. And so I want to walk you through actually using phase 0, both with the CLI and the JS SDK. And I'm not going to sugarcoat it. It's tricky. The resources are incredibly constrained, and the CPU issue is legitimate. So the CPU issue, let me just talk about that for a second. It has something to do with when you submit a transaction or deploy a contract, there's like a 2-step process in the CLI, and even with like the JS SDK, you've got 2 options. First is simulation, and then a submission. So to actually get a transaction that you can submit, a Sorbonne transaction, you have to collect a lot of stuff. All of the read and write bytes. So like, what ledger entries are you going to touch? What authentication do you need? And then of course you're collecting the resource usage for how many CPU instructions your transaction will use. And so simulation is what we use to collect that information so that we don't have to guess or hope for the best or set it to the max and end up paying a lot more than we would need. So simulation is really helpful for that. It does almost like a dry run of your transaction execution. The issue is that currently that simulation isn't perfect. It's not a perfect mirror to what happens in core. And that results in a discrepancy in particularly the CPU. And in phase 0, that really matters because you only have 2.5 million CPU to play with, and if simulation estimates more, or estimates less, but then you actually need more, you're really going to feel this. This is not something that's like unique to phase 0 or something new. The CLIs actually had a flag in it for setting the CPU. The JS SDK has this leeway flag when you do a simulation. You can, of course, set your own CPU. You don't have to use the one that comes back from simulation, but all this to say, simulation can essentially give you an answer that may not be correct. And that's where we're hitting this error. Let me see if I can actually trigger this error quickly. I'm gonna actually do this. So the first contract that we had, and I'll just copy it over here. Soroban contract, invoke ID. I have a network. The line wrapping gets me. Called Live, which is connected to my RPC endpoint that I have in my DigitalOcean droplet. I think. I hope it's not still connected to the one that I was running on my Mac. My source, nope, it's not called Live. This one's called Public, and my source account is called Live. And let me just run a help on that, make sure that all works. That needs a little dash. And so this is a call function. And if I call this, I think we'll get an error with that CPU. Yeah. So hopefully, perhaps you have seen this. This has been popping up all over the place. It's a little bit odd to me that the CPU comes up even like the most basic of calls, but it does. But thankfully, we've got two options that we can use here that I think are worth calling out if you're unfamiliar with them. The first one is this isView flag. So this call method is actually not writing anything to the blockchain. It's just returning a value. And so this particular flag essentially says, I don't want to write anything. I don't want to sign a transaction. In this two-step process of simulation and submission, I only want you to return the result of simulation. And so this will bypass this particular issue of, I don't care what the simulation is telling me it's going to cost. Don't actually submit it. Just give me the return value. And so that's the return value. So that's the first option. Obviously, if you're just using isView, you're not pushing anything you're not changing anything or uploading anything. You're just returning the simulation results. The other one is this very helpful instructions command. And this is the thing that we're going to want to play with. And this is not a leeway, so I actually probably won't get into it much today, but there's kind of like two things you can do here. The first is just override the CPU instructions that simulation sends back and say, I don't care what you think you need. I'm going to override this and set this to whatever I want. So in my case, I might set this to 2.5 million, which is the max for phase 0. Leeway is a little bit different, where it essentially is saying before simulation, go ahead and add an additional amount of CPU on top of whatever the simulation sends. And this is important because if simulation comes back and it says, this is going to cost 50,000 CPU and your leeway is set to 2.5 million, your transaction is going to fail because you're actually trying to send a transaction that's beyond the max of the phase. And this is obviously important for phase 0, but it'll be important for any phase because there's always going to be limits. And if you're adding leeway on top of what is coming back from simulation, it's possible you could go over the max. So just be aware of that there's kind of these two options you've got here. I like having both because it's probably not the best idea to always set something to the max, because this is absolutely going to mean I'm paying for CPU that I don't actually need. But that's okay for phase 0 because it's still pretty cheap and low. But once we get to phase 2 and beyond, you're not going to want to use this like just set it to the max mentality. You're probably going to want to use something like leeway, which is essentially saying just put some comfortable buffer. I know they're definitely the team is working to ensure that the is it called congruency? The parity between what happens in core and what happens in simulation is far closer. So you won't have to have this concern of what comes back from simulation being incorrect. Maybe we'll get this to 100%. I don't know. Don't pretend to be smart enough to know what all goes into trying to simulate quickly what core does in a ledger. Regardless, for this particular instance, we can set this to the max. We could try and maybe we'll just shave off 1 million and see what happens. I don't know off the top of my head what simulation is assuming it should be. Looks like 1.5 million is fine though. So I didn't need to set it to the max. This one got me past that initial issue. And again, this particular flag just disregards anything. This is not leeway. This is just overriding. So cool. That is how you can use the CLI. Now, this is only for Invoke that this instructions flag is available. This instructions flag, it's a lot of us have been trying to do that Soroban contract asset deploy, right? But there's no instructions flag for deploying your Stellar asset contracts. So you're just always going to fail right now for phase 0. Not to fear, however, because now we move to the next step in our demonstration demo with the 7 minutes we have left. I have a JavaScript single file here where I will go through the process of actually using the JS SDK to deploy Stellar asset contracts and then invoke them. I am not going to do this on a live network because I'm going to be showing secret keys and I don't want to lose any money. So this is all going to be happening on a standalone network, which you'll recall I shut down. So I'm going to start this back up. I've got a quick start here. This is going to start up quick start. If you're unfamiliar with this limits flag that was added a while ago, there's default. One that I really love is unlimited, where you can essentially say, to heck with phases, just give me all of the resources, which is a really nice way to test upper bounds of your contracts to see how much resource you actually are using. And then you can scale back your contracts as needed. So rather than hitting errors and having to like slowly whack-a-mole your limits, just set it to unlimited and fiddle with all the places you might be exceeding. But we're going to set this back to default, which is phase 0. You'll notice this is a local network. We're standing up our Soroban RPC, and then I'm just going to execute that. The nice thing about this too is that these networks spin up incredibly quickly. So just like that. There we go. It's online. So if we go to here and we go to localhost 8000, we can see our local network has already stood up. Beautiful. Let's go back over here. Okay, so we've got 2 accounts. Before I get into the code, I want to remember to make sure I fund these 2 accounts. So I've got a from key pair and a to key pair. So I'm going to just make sure both of these are funded because when you don't have FriendBot in the network, in the public network, obviously. And so I don't want to have a script that is assuming using FriendBot. I'm going to assume that these are already live on a network for the rest of this script. Let's start up at the top real quick. I just set up some variables for the standalone network. I set up a key pair for a from account and a to account. I also grab the from account, which sets up my sequence, grabs the sequence number, You'll notice that I'm using the RPC server. There was some conversation about should you use Horizon or should you use the RPC for grabbing sequence numbers. You should use the RPC, and there's even a really nice method inside of the RPC called get account on that RPC, which makes a call to the get ledger entries method and kind of just wraps that up really nicely. And then inside of this result, you've got an account ID, an increment sequence number method, so you can artificially increase the sequence number for this account. And then you can also get that sequence number. But I just grab both of those and put those into a new account because this account is what we'll use when we do transaction building. And then I've got a to key pair and a to public key. This is where we're going to take, essentially what we're going to be doing is taking the native XLM token, wrapping it, and then we're going to submit another transaction which actually sends some XLM from the from account to the to account. I've got my asset here. I'm just going to do asset native, but you could just as easily use another contract. Another asset, one of the trust line based ones. I will say I have been unable to actually submit an invocation. So like a transfer or a mint method on anything but the native asset. And I'm almost positive that's because we're right on the edge of the upper bounds of limits. And fun fact, when you're submitting transactions with non-native assets and it touches trust lines versus just like the account. So there's something in the ledger values there. So there's the values are larger. So it's going to be slightly more expensive to do transfers with non-native assets. So I was fiddling around earlier today and found that out. But you can wrap them. You can deploy them. We're cutting out the wrap function out, or the wrap nomenclature. It's deploy. So apologies for that. We will be deploying this native. You can definitely deploy on phase 0 other assets. Overcat proved that to us many, many times. I think he's been deploying a bunch of those. But I haven't been able to use them. But you can use it on the native asset. So anyway, all of that to say, moving on. We're going to, in this block of code here, we're going to create, there's a nice operation for creating Stellar asset contracts. And it takes in an asset argument, which I included up here. Then we're going to take this and build a transaction from the from account. We're going to include this operation. There's nothing interesting where you'll notice like a valid Sorbonne transaction will have the set Sorbonne data method here, but we're not doing that. We're just setting the most bare bones of transactions because what we're going to do with that is simulate it. We have a method here which takes in a transaction and then it simulates that transaction. And if it's a successful simulation, I'm going to go in there and adjust the resource fee and the resources. So I'm just going to set these to the max of phase 0 for all of these values. So it's CPU instructions. You can see this right here. CPU instructions, read bytes and write bytes. I don't want this transaction to fail. I want it to succeed and have the best chance. So I artificially go into what came back from the simulation in the transaction data, the resource fees to 0.1 XLM. And then I set the resource fees to max to give me the best chance of success. Then I take the simulation and the previous transaction, I smush those two things together with this assemble transaction. I build that transaction out, and then I sign it with the key pair, which is also coming back from that send transaction. So that should be the from key pair. That should now make a valid transaction here, which we can then use the RPC to send that transaction. We then go into a nice little loop where we're going to be looping over this get method. So basically what this does, unlike, I guess the Horizon does it behind the scenes, you just don't realize it. There's like this two-stage process when you submit a transaction to the network. The first is just like, did it make it? Was there a sequence number issue? Did I forget to sign my transaction? Assuming that everything looks good and the network is willing to accept my transaction, it'll come back as a pending state. So if it's not pending, just tell me. I'll cry about it. We'll figure it out. We'll try again. But if it is pending, move on. And now we need to go into this polling method, which again, Horizon does this behind the scenes, but RPC allows us to kind of insert ourselves into this process to do a little bit of that work ourselves. And that is to just start getting the transaction like, hey, has it been submitted? Has it resolved? Has it resolved? Does it fail? Was it successful? I need to know. And then depending on the response here, it'll either be failed, not found, or success. So if it fails, again, we'll cry about it and log it to the console and figure out what to do. If it's not found, we'll just give it another try. We'll wait a second and try again. And if it was successful, fantastic. We'll just return the result of the success. And to ensure I don't loop for all of eternity, I'll put a limit on this for 30, which 30 for 100 or 1,000 milliseconds is 30 seconds. Set this to whatever you desire, but that is the looping logic. Okay, so that will then, assuming that eventually comes back as successful, whatever the return value is inside of this get res, which again you can see from the TypeScript here, it's a get successful transaction response, which should have a return value object here. And I did put an any on this because there was a weird undefined issue and I ran out of time to try and fix that. So any good TypeScript people can help me work on that whenever I get the code out. Okay, so once we get that though, this will return back a contract address. Well, actually it returns a return value, which is an address, which is a contract ID, which I put into an address.contract and get a toString. Not beautiful, but eventually I'll get back this nice string. There's probably an easier way to do that, but that's why I'm doing it for now. Once we've that's the actual deploying of the contract. Next, we actually need to invoke it, and this is kind of do whatever you want. You can mint, transfer, just look up the balance, etc., etc. I'm going to build out an operation for an invoke contract function. This is one of those instances where the TypeScript bindings really help, so that you don't have to like figure out what your args are by yourself. Give it a contract hash and it can build all of this out for you. But in our case, we just deployed it, so we don't have the contract hash. So we're going to have to assume what it is going to be and then build out our invocation on our own. But I know that there's a function called transfer and its args in order takes a from argument, a to argument, and an amount argument. So we just take the from public key, needs to be a smart contract value, the to value, and then I'm going to take, takes it in stroops. So this would be 10 of whatever our asset is, which again comes from the contract address, which was what we just wrapped. So this will be the native, but takes that in. This is a nice way to ensure that what we get is this I-128. I don't know how to build a valid 2SC val for an I-128. So I just use this nice native 2SC val helper method. Sweet. Build that out into this operation, and we do the exact same thing that we did before. We build a really simple transaction, send it to the send transaction, and return our result. Okay. Oops, I'm using Bun.js for this. I really like Bun.js. It allows you to write these TypeScript single files. It's very fast, but if you don't, that's fine. You can use whatever inferior packaging tool you would like. I'm going to use bun run and then the clean sac deploy, the file name here, and then we'll just run that. We're missing the, I think I changed something. Let me just back this up a little bit. Try again. Oh, shoot. I think, my simulation is failing and I don't. I wonder, I did fund those 2 accounts, right? I'm gonna have to, if you've been following, I expect whenever I look back at chat for someone to figure out what I have done because we're already over time. Both of those are funded. It is possible, I don't think this has already been funded. Oh, no, that should work. It is possible that I was running this in the unlimited budget, and there's something with my budgets that aren't working. Whoops. Let me see what the simulation failure error is. We'll try and debug this quickly. Otherwise, I'll get the code into a gist and paste it, and then we can debug in post. Error. I don't think this actually has anything. This should probably be a nice little string. Contract already exists. Somebody's already. Wait. I think maybe I already ran this. That seems odd that I would have done that because I just started this. But it is possible. Let me start this back over again and get these back online. It seems a little odd that the contract would already exist. But if it does, we can just skip the first one. Oops. My network's fast, but it's not that fast. Let me try this. I wonder if the local deploys a native asset already. Let me, if we don't do that and instead we do this. Yeah, interesting. This one, so my native asset contract has already been deployed. By the time I get to here, I don't know if that's because my local quick start magically deploys the native contract for me. So I don't need to deploy it myself. But regardless, once it does exist, and this is the code which you can again get by running Soro on contract asset ID asset native network local at this point. Source account on default. I think I'm going to have to find. Oh, is this G4 address? Yeah, so that's already been deployed. So the nice thing is when you get errors, you can just simulate or you can just console log them, and there's usually helpful errors. But we don't need to deploy our contract. It's already been done. But this is the code that you would use to do it. And you can change that asset again. And then for the method to actually do something with it, in our case, send some native asset, we can look over at our address here and see that we've got that 10. So we did the friend bot there, and then we've got an additional 10 if we were to run this. Oops, run that again. We should see this increase from 10 to 20. So there we go, and that's super tiny. But yes, hopefully that is somewhat helpful and interesting. I will grab this code and put it into a gist and paste that in our recap notes. I think there's a lot of messages here that I probably need to go back and read quickly. If you do have questions, I realize that we are 10 minutes over, and apologies for that, but you can't slow me down. I'm just too excited. But I'll read back through these, make sure there's nothing I need to answer, and then we will wrap up. Yeah, the usage on phase 0 that we weren't supposed to use is quite high. I love it. Any plans to include instructions in Sorbonne contract deploy? Hopefully it won't be needed once we get to phase one. I think if we keep running into CPU issues, yeah, we definitely need to include in instructions for contract deploy. I honestly think we should probably include it anywhere that we're doing simulation. But that would be a good thing to put as an issue inside the Sorbonne CLI repository. You can transfer native tokens to native contract. Interesting. Is that a new way to brand new ways to burn lumens? First PR, remove wrap terminology. There is no wrapping in Stellar or Sorbonne. There is deploying. All right. Yeah, somehow Overcat managed to beat me to wrapping, not wrapping, come on, Robert, deploying XLM on my local machine. Scary. Yeah, it seems a little bit odd to me. I don't think, I'm not including a volume, so I'm not sure why when I close it and then spin it back up, somehow native is magically there, but maybe there was a recent push to the quick start and native. I know there was an issue that I saw even today because I often forget to wrap up native token, and there's an issue outstanding to just automatically make sure that the asset native is always available in testing networks. So maybe that manifested itself. I'm not sure. Yeah, but I've got the remove flag. So when I shut it down, it junks the container. So it's always a fresh container. So I don't know. It's mysteries for another time. But thank you all so much for hanging out. Any final comments? Naman, anything to add? You've been hanging out for a long time.
No, this was great. I learned a lot. I tend to sort of work at the protocol level, right at the core level, and I don't get off. It's not often that I get to sort of see what folks are building on top of it, and so this entire R was pretty amazing. Some crazy shit going on.
Yes, it's a lot of fun. Good times. I'm going to fondly remember the phase 0 days.
Yes.
The day of the devs.
Yes.
All right. Well, if there's nothing else, I will wrap it up here. Again, appreciate you all hanging out, and we will catch you all next week for the protocol meeting.
Yep.
See y'all later.